Hey everyone, welcome to the beginning of chapter 3, where we're going to talk about organic nomenclature, which is what I like to call speaking organic chemistry. This is all about how we name organic compounds. So I want to, give a little bit of an introduction and disclaimer to this part of the unit that chemical nomenclature can be really complex. There's a lot going on. There's a lot of different types of atoms and functional groups and molecules. So it gets to be a lot really fast. And I just want to throw out there that not all chemists just have it like all in their heads at any given time. We know some of the basics, but a lot of the time we'll use programs to help us name things or look them up. So as I say, it's really important to have some level of just basic knowledge about how we name things so that you can name simple compounds, and that'll help us to be able to communicate to each other about what kind of molecules we're looking at and what we're trying to do. Otherwise, we're just going to be sitting there staring at each other thinking that I have no idea what this person's talking about, and the other person will say, I have no idea what Grace is talking about. So the reasons that it is a little bit of a funky unit, and a lot of times students don't love it, is that the names can get really long and complex, and I promise we won't do too many that are really, really crazy complicated, because when it gets to be that way, what chemists like to do is to just use acronyms instead to save time, to save space, to make it easier to write. And then other things that we'll do is chemists will just name things after themselves. So there's plenty of examples of that, but you'll find a bunch of different compounds that have some person's name on them just because they, helped discover it or helped develop it. And, that's totally fine to give credit where credit is due, but it has nothing to do with the systematic way that we try to name our compounds. So the other part of this is there's a lot of things from way back in the day, some historic names that people came up with way back in the day, and they just kind of stuck around. So we'll actually see a couple examples of that later on. But this is all just to say that for the above reasons, we're going to have to do a little bit of nomenclature here, but it won't be a huge focus after this unit. So specifically what that means is on the Unit 1 exam, there will be questions about nomenclature. On future exams and the final exam, there's basically going to be no nomenclature, maybe on the final, but I'll let you know. It won't be on the other unit exams, and we will still need it, like I say, to communicate with one another about the types of chemicals we're talking about, but you won't be tested on it explicitly, except during this unit. So we'll get through it for now so that we can talk to each other about this, and then we'll move on to some hopefully more interesting stuff. Okay, so how do we name things? Well, it all centers around this base name, right? And so this base name is derived from a chemical's basically number of carbons, or I like to call this the carbon backbone. So that's a metaphorical backbone, but kind of the big spine of the piece that gives the structure to the compound. And then we're going to, add some modifiers to that to explain what else is going on. So we add modifiers both before and after that base name. And that'll give us more info on the other stuff that's going on in a chemical. So like I say, it's based on this backbone. So if you have a backbone with a certain number of carbons, it has a different base name. So let's go through these base names together. So for one carbon in your backbone, that has the base name of meth. So we're going to be able to put things before and after these. So these are just the kind of root names that go with this number of carbons. 2 carbons is eth. 3 is prop, P-R-O-P. 4 is bute, which looks like but we pronounce it bute. 5 is pent. And then some of these will make more sense with numerical prefixes that you've heard before. 6 is hex. 7 is hept, the PT at the end. 8 is oct, 9 is non, and 10 is dec. So like I say, some of these later ones may be familiar to you from like geometry, mathematics, that kind of thing. The first few have some other name origins, maybe a little bit more historic in nature. Let me move that down so it looks a little nicer. So you will have to commit these ones to memory, especially the first 6. These are going to be a big deal because you're going to see those a lot. These other ones you also need to know, but focus on, if you want to start smaller, start with the first 6 first. Okay, so once we have those base names, we can start to actually name some stuff. So the simplest things that we can name are compounds that have just carbon and hydrogen in them, right? So if we have, pardon the scrolling, if we have carbon-carbon bonds and carbon-hydrogen bonds that are all single bonds, no double bonds, no triple bonds, just all single bonds, these compounds are broadly called alkanes. And that's a term you might have heard before in general chemistry, but perhaps not. So alkane is the big family name for these types of molecules. And those come along with a specific suffix that is as follows, ANE. Okay, so it's kind of the end part of alkanes there. That's how we are going to first name these kind of most simple compounds, is by taking our base name and adding the suffix to it. So let's do some practice examples. So first things first, let's try this one. How many carbons are there? Quick little quiz of your carbon counting skills. Count the carbons, go back and refer to that prefix if you need to, and then answer the question, what is the name of this compound? Hopefully we all counted 4 total carbons here. So the prefix for 4 was bute. And then if we put the suffix on there, ANE, we get butane. Some of you may be familiar with butane. You may have heard that before. It's a component of fuel. You can have propane or butane powered, things like grills. So there's butane. Let's try another one. All right, take a moment, count these carbons, and predict the name of this compound. There are 1, 2, 3, 4, 5, 6, 7 carbons here. So the prefix for that is hept. Add our suffix ane, and we get heptane. Nice work. Okay, one more. What about this one? This one is a little bit different than the ones we were looking at before, isn't it? So if we count this one up, we've got 1, 2, 3, 4, 5, and 6. So that looks like it would be hexane, right? Well, it looks like it would be that, but it's not, because it has a difference compared to these other 2 molecules that we've looked at. So let's get rid of these carbon counters. When we looked at butane, we just counted 1, 2, 3, 4. When we looked at heptane, we counted 1, 2, 3, 4, 5, 6, 7. When we count this one, we get 1, 2, 3, 4, 5. And then this one kind of like is off on its own. It doesn't really fall into that chain or that backbone, right? So because of that, we have to name it slightly differently. So this is not hexane. Instead, we're going to name it based on this main chain that I've highlighted in blue, and then we're going to deal with this separately. So how do we go about doing that? By naming it as a side chain. So we want to focus on a main chain or the longest carbon chain when we're naming. And then anything else we consider as a side chain. So we take the side chain name and, we take the base chain name and then we're going to add this as a modifier to it, essentially. So in order to name the side chain, you want to count up how many carbons are there and take that sort of number of carbons base name and add a different suffix to it. And that suffix is YL or ul. So we'll give an example here in a second. And then you're going to add some numbers to your main chain to tell us where this side chain is. Okay, so let's revisit that example from before. As we looked at earlier, we said there's 1, 2, 3, 4, 5 carbons in our main chain. So we can start off by saying that we know that the base name of the whole chain is going to be pent, right? This is a pent, and since it's all carbon and hydrogen, we know that it is going to be a pentane. But now we have to look at this side chain and name that differently. So how many carbons are there? Just one. So we want to name that with the carbon number base name for carbon of 1, which is going to be meth. And then we add the suffix to that, YL. So this that I've circled here in red has the name of a methyl group or a methyl side chain. So then let's add in our numbers to tell us where on our main pentane chain that side group exists. And if we count it up at the 3 position, we have a methyl group. So we have the overall name of this compound is 3-methylpentane. Okay, so just to reiterate a little bit, we find our base chain, we name that, and then we find our side chains, give that its own carbon base name and the suffix -ol to tell us that it is a group or a side chain, and then put it at the front of our base chain name. Okay, so let's try another example here. So similar looking compound here. We're going to rely heavily on this 1, 2, 3, 4, 5 carbon main chain. And then it looks like we have a fairly similar situation to here what we had before, right? That looks like a single carbon. So that is probably going to be another methyl group. Okay, so what's different about this? It's just at a different position along the chain, right? So if we were to put some numbers on here, then we could figure out this name as well. So let's just put some numbers in like so. And we could say, oh, it's sitting at the 4 position. So not too bad, right? But there's something a little bit amiss about this. What's something that we could maybe make a little bit better or nicer here? This may be a total guess for you, but go ahead and answer the video question now to see what you think we should change to make this name a little bit nicer before we finish writing it. So maybe it occurs to you that this methyl group being at the position number 4 is correct the way I've numbered it, but why is it a higher number than 3? Again, if this wasn't common sense, don't worry, it's all a nomenclature thing. I'm not expecting you to know this off the top of your head. But it's not as nice to have it on a carbon position number 4 when there may be an alternate way of numbering that will be a little bit better. So I just arbitrarily numbered it from right to left, but if we numbered it from left to right instead, we could use a number 2 instead of a number 4. And so that's a smaller number. That's what we like to do to just make things as simple as possible, is always use the smallest numbers possible. Okay, so knowing that, now go ahead and answer the video question to predict what the name of this compound is. All right, hopefully you agree with my logic that it's better to have a smaller number just to make it as simple as possible. So you're going to stick with the number 2 for the position of that methyl group, and then we will give this the overall full name of 2-methylpentane. Just like so. Okay, so what happens when you got more than one? Right, so here we've had kind of a main chain and then one little thing hanging off of it. If you have more than one, you're going to do the same process to identify all of your side chains, do all of that first, and then you're going to put them named in alphabetical order. So let's take a look at this example here. I'll give you a little starting hint. to look for our main chain here in the same way. 1, 2, 3, 4, 5. And then go ahead, give it a shot. Guess the name for this compound. Let's take some time to identify our side chains. Up here at the top, we have our friend from before, a single carbon for a methyl substituent. But now we have a second one, which is this group down here, which now consists of 1, 2 different carbons. So we have to go for the 2-carbon base name, F-E-T-H, add our ol suffix, and then we get an ethyl group. So looking at this and putting all the pieces together, we have to do them in alphabetical order. So even though methyl is kind of like that's number 1, has 1 carbon, we want to start with ethyl because that is alphabetically going to be first, E before M. So I'm going to write this really small here and try to make some room. We want to start with ethyl, and again, we want to number these so that we can tell our relative position. Practice numbering either, and you should number as many possible different ways as you can. If we number this direction, like we did in the previous example, we'll see that we have our ethyl group at 3 and our methyl group at 4. That's okay, but let's try the other way and see if that's any better. So if we start here, 1, 2, 3, 4, 5, then we get groups at 2 and 3. So those numbers are overall lower, so this is the numbering that we want to stick with. So now we can say we have a 3-ethyl group, 2-methyl, and then our base chain name is still the same, pentane. Okay, so make sure you leave yourself enough room when you're writing out these chemical names because like I said, they can get long and a little bit complicated too. So let's move on to just a couple other things that you should know when you're looking at these chemical compounds because these are some common things that you will be encountering. Rings, we're going to see a lot of rings in organic chemistry. They're very useful functionalities and they're named essentially the same. They just get one little extra thing in here. They get this cyclo prefix and then that is added to the base name. So here we have 1, 2, 3, 4 carbons on this square molecule that is cyclobutane. And then we can just kind of keep going up the list of carbon base names to add all these cyclo compounds to them. So definitely the first 3 of these rings are going to be incredibly common. Cycloheptane, it's there, but drawing a 7-membered ring is kind of, it doesn't look so good. So I'm probably not going to make you guys do that too much. And you can also see that my tablet nicely kind of auto formatted these 3 for me, but it couldn't figure out cycloheptane. Okay, so let's try this example. Here, if we have this 6-membered ring and a chain coming off of it, here we go. Let's think about the name for that. It's our 2-carbon side chain from earlier. So that is an ethyl group. And it is coming off of a 6-membered ring. So that is our cyclohexyl. Cyclohexane is our base name, and then we would give this an ethyl prefix. But one question here is sort of what is the number for this carbon? Since it's a ring, you can number anywhere and you can go all the way around, right? So the way that you would go about this is starting the numbering at whatever the most important functional group is, and that's 1. Right? So that we have just the 1 functional group, we put our number 1 there. So this would be technically 1-ethyl cyclohexane, but if it's the only thing, we often drop this off. So I'd be willing to accept either 1-ethyl cyclohexane or just ethyl cyclohexane. Now we want to think about some other functional groups because alkanes are great, but they're kind of boring. They don't do very much. Other functional groups do a lot more interesting stuff and compose more interesting molecules. So we want to know what to call those. Let's start with alcohols. We're going to see a lot of alcohols just throughout this, throughout this semester. They're really useful functional groups, so we want to talk about those. The alcohol is this group that has any kind of group that has the OH, right? Like so. And the suffix that you're going to add to a compound name to show that it's an alcohol is OL, all, right? And that comes from alcohol. There it is right there in the name. So if we practice naming this one right here, again, find your longest carbon chain. 1, 2, 3, 4, 5. Told you we're going to get a lot of use out of that pentane chain. And then at the 2 position, we have an alcohol. So we would call this 2-pentanol. Okay, so this one is a little bit different. It's not just pentol. There's this anol, right? So we kind of have pentane. We've chopped off the E, and we make it a pentanol instead. So the alcohol one is a little bit funny. Come back and practice that one. I'll make sure you get some practice on your homework and with some extra practice problems as well. Amines are also very common. These are big common in biology, right? So the amine is anything with an NH or just really a nitrogen in it. It can have a lot of diverse structures, so you have to look out for it everywhere. But we'll just do this example. When we have an amine, instead of a suffix, it's a prefix. So this fits a little bit more with the other types of examples that we've done. And the prefix is amino, right? Amine, amino, I think it makes sense. So we have the same kind of chain situation here. And spoiler alert, I've designed these so that they're all at carbon number 2. We would call this 2-amino pentane. Not too bad, right? One more. It's actually 4 more, and that's the halogens, but they're all named in a very similar way, so they all go together. These also will have a prefix at the beginning, right, of the carbon chain name that is going to look something like the format of halo, right? So they're all halogens, but what I want to say by saying this is just that they all have this O at the end. So for fluorine, it would be fluoro, U-O-R-O. Don't spell it fluoro, right? Or do spell it fluo. Just be wary of spelling fluorine wrong because it's easy to spell it as flourine, like baking flour. So just watch your spelling on that one because spelling absolutely counts for nomenclature. The other ones would be chloro, bromo, and iodo. So just kind of taking the element name, chopping it off partway, and putting the O in there at the end. So if we name this practice problem, that would be 2-chloropentane. Okay, so with that, those are kind of the base rules that you need to know. Practice, practice, practice these rules, and they'll get to be a lot easier, right? And then, like I said, I promise we'll get through it on the first exam and not concern ourselves with it too much. We'll learn more fun stuff. And speaking of fun stuff, let's talk about some of the weird places that nomenclature names came from. Just a couple little quick examples. So the name for methyl group comes from the Greek for methy, which kind of means like wine or alcohol, and hyl, which means wood. So this is interesting to me because that's where methanol was sort of first isolated and started to be used, was when they were fermenting wood into this wood alcohol. That's where they were getting these spirits of methanol, right? Wood alcohols, and that's where the name methyl comes from. Ethyl, sort of similar, but not exactly. You can't break it down as nicely to the Greek. It comes more from something like ether or aether. And this, I think, has a little bit less of a solid history, but the aether is something that some folks used to believe, and maybe some folks still believe, is just this invisible substance that's all around, and we can't feel it or sense it, but it has these properties that do things with physics and electricity. Anyway, that could all be a bunch of pseudoscience, so I'm not going to recommend that it's necessarily related to chemistry, but if you're interested in it, there's probably a lot of good reading out there that you could do. And then let's take a few more recent examples. A modern mashup. Something that a lot of us may be familiar with recently is Lysol. It's a household cleaner. And this name allegedly came from kind of a mashup of the terms lysis, which is a biology-like term, right, to kind of break things up, or maybe like dissolve. And this cresol, I'm not exactly sure how you pronounce that one, but this is a group of molecules that look like this. You don't need to know this. Again, just a fun fact. Molecules that look sort of like this, that were a component of the original Lysol formulation. So the idea being that they're using these cresols to lyse or break up and remove dirt as a cleaning agent. And last but not least, prescription drugs. So where do those names come from? I still don't know. I looked it up. It seems like there are some rules to it, but when you look at the drug name for the actual compound and then the name that's marketed, they don't seem to be similar at all. So I think they just kind of make it up there to pick drug names that sound nice. And hey, you know, if that's what they want to do, that's what they can do. So anyway, there's just a little bit of a fun factoid there for some nomenclature, and I'll drop more in along the way as we go through the semester. But for now, what's most important is getting some practice and review on all of these nomenclature pieces. So the 10 base names that you need to know for 1 to 10 carbons, naming those side chains, getting some practice with doing that alphabetically, making sure that you're identifying the lowest possible numbers, and then knowing those specific prefixes and suffixes for functional groups, including alcohols, amines, and halogens. And then with that, I tell you to start looking ahead into the rest of chapter 3, but actually, we're gonna break here. Now, what you got to look ahead to is getting ready for exam 1. Exam 1 is going to cover chapters 1, 2, and the nomenclature part of chapter 3, right? So just the nomenclature, nothing else in chapter 3. We'll finish chapter 3 in the next unit. So as you're studying, go back through these videos, do the quizzes again, do the book problems, retrace your steps on your homework. Let me know if you have any questions, and I'll be trying to put together some extra review materials and a study guide for you before the exam. All right, so be in contact, hit up that discussion forum, send me a Canvas message or an email, and take care. I'll see you in the review for our exam.